right, here we go. Good morning. Oh, where did my helper sheet go? All right. You guys are reserved. We were driving to school today, and I was like, hey, guess what? To my 3 kids in the car. And they're like, what? I was like, it's Thursday. Like, I just like to point that out. Thursday? Crazy, right? Okay. What a weird week this has been. Okay. So today we're looking at equations. We want to be able to complete a table of ordered pairs using an equation in 2 variables. 2 variables meaning it has an x and a y in it. And what that means is if it has an x and a y, then we're going to be able to actually graph those x and y ordered pairs on our coordinate plane and create a picture. So equations as functions. Functions can be represented by an equation or rule. So a lot of teachers like to use the word, this is the rule. The equation will generate ordered pairs by taking an input value, something we're going to plug in. That input value is an x value. We're taking an input, we're plugging it in, and it results in a certain output, which happens to be our y value. All right, so we have what we're plugging in, and we have what we're getting out. The x value is always called the independent thing, I-N-D-E-P-E-N-D-E-N-T, the independent variable. And the y value is always called the dependent variable. So the x is, you're going to find out, we can pick whatever numbers we want for x. They are independent. They are free to be whatever they want to be, okay? So we're going to pick x values. Eventually, we'll pick our own. And then what happens is when we plug in that x value to the rule determines what that y value is going to be. That's why it's called it's dependent. That's why the y is the dependent variable, because it really depends on what the rule happens to be. And so we have our independent and dependent variables, and the graph of an equation is the set of all its ordered pairs, which form a line or a curve. In this class, we focus on lines, but starting in algebra, you guys learn that there's all sorts of other curves as well that are pretty predictable. All right, so complete each function table. So here we have this equation right here. I know that it's an equation because it has an equal sign. It's an equation because it has an equal sign. And what we have is this portion right here, the x plus 7 portion, that is called the rule. And that's the rule that's going to help us figure out what the y is equal to. And so we have our rule right here, which is x plus 7, that I'm going to write in my little table here. And what we have is we have our x column. These are x values that we've decided to use here. We could really choose any x value we want, -10, -5, -4, okay? But here we chose some nice values. And what we're going to do is we're going to replace the x with the -1 in our rule. So instead of x, we're plugging in the -1. And then we're going to add 7 to it. Because that's what the rule is telling me to do. It's saying, hey, add 7 to your x value. What is -1 plus 7? 6. Beautiful. And then what we just created was an xy ordered pair. So our ordered pair is -1, 6, and we can use that to graph it, which we'll do in a little bit. What are we going to plug in now? Yeah, so we're going to do a 0 and then add 7. What is 0 plus 7? 7. What's our ordered pair? 0, 7. All right, what are we going to plug in now? A 2. Instead of the x, we plug in a 2, and we're going to add 7. And what do we get? 9. Beautiful. What's our ordered pair? 2, 9. 2, 9. Yep. All right. And then we're going to plug in a 4, and it tells me to add the 7. And what is 4 plus 7? 11, and that's our y variable, so we can make our ordered pair, which is 4, 11. Okay. So all we're doing is replacing our x. Is that pretty easy? It's pretty easy, huh? All right. Let's skip down to number 3, which I think is a harder rule, actually. Again, we have this lovely equation, and we have this portion right here. That is our little rule that we're going to use to figure out what the y is equal to. So I'm going to write that at the top here so I know what I'm doing. Now this one is actually really, really, really tricky. There's something missing here. What's missing? A 1. Yeah, there's a little invisible 1 there. -1 times x. I'm going to write that in because that might be really, really, really helpful for you. All right. This says we're going to replace the x with a -5. So I want you to be very, very careful as you write this. That -5 has to go right here in place of the x. And so I'm going to rewrite my rule here. 1 subtracting the 1. And then when we plug in, I want you to make sure that when you replace your x, you use parentheses. So that is -5. So it's a -1 times -5. That is so tricky. This is not a problem I would have done second here. So, order of operations. What do we have to do first? Yeah. So there's really nothing to do inside the parentheses, but this is the product right here. We need to deal with that first. What is -1 times -5? 5. And so we actually end up, this is a horrible problem to do. We're going to come back to this, I think. This is a horrible problem to do. I don't want to do it. Let's skip it. Let's go to 4. This one will be better. My rule is right here, the 2x minus 7. What are we replacing the x with? A 0. So I have a 2, and again, I'm going to plug in my 0 in place of the x, and remember to use parentheses so you do it correctly. All right. What is 2 times 0? 0. And then we have to subtract 7. What do we get? -7. All right. So I have an ordered pair of 0, -7. Now I'm going to plug in what? The 2, thank you. So I have a 2 in front. Now the x gets replaced with a 2, and then I have to subtract 7. So this becomes 2 times 2, which is 4 minus 7. -3, very good. What's my ordered pair? 2, -3, beautiful. Now my x is going to become a 5, so I have 2. Plug in the 5 and subtract 7. We got to multiply first. What's 2 times 5? 10 minus 7? 3. What's my ordered pair? 5, 3, beautiful. And now I'm going to plug in an 8. So I have my 2. I'm going to plug in an 8. And then I'm going to subtract 7. What is 2 times 8? 16 minus 7? 9. And we get an ordered pair of 8, 9. Beautiful. All right. We chose many different values for x. And we can really choose anything we want, okay? But there are some very special numbers that you can choose if you have fractions. And so this is a great one here. Here's our little rule. 1/2 of x. Half of x minus 9 is our little rule. Now, we chose some very nice numbers here. What do you notice about all the numbers we chose here? They're even. Yeah, they're even numbers. We can all take half of them really easily. So we can do choose some very strategic numbers. I have a 1/2 in front. I'm going to plug in a -6, and then I have my subtract 9. What is half of -6? -3. And then subtract 9? -12. Beautiful. Can you use a calculator? Yes, you can. And you'll notice I'm specifically not using a calculator today just because it's good to talk through these things. But yes, if you need to, you can use a calculator. All right, now we're going to plug in a -2. So I have 1/2 replacing with a -2 and then subtract 9. What is half of -2? -1. Yeah, half of 2 is 1. So half of -2 is -1. So we got -1 subtracting 9. -10. Beautiful. All right, so we have a -2 and a -10 for my ordered pair. And I have a 1/2 in front, and I'm plugging in a 0 this time. And then I'm going to subtract 9. I love plugging in zeros. They make life really easy. What is half of 0? 0 minus 9? -9. Yep, -9. All right, so we have 0, -9. Beautiful. And last one here, we have half of plugging in, replacing the x with a 14, and then subtracting 9. What is half of 14? 7 minus 9? -2. So we have a 14, -2 for our ordered pair. All right, questions on those? It's pretty easy, right? Not too bad? Okay, turn the page. Given each function and its domain, we talked about domain yesterday. Domain are simply x values. Remember, they were alphabetical, x, y, domain, range. So given each function and its domain, or certain x values, we want to find the range values. Well, what are range values? The y's, yeah. So really, this is just code for I'm giving you x's. Can you tell me what the y's are? That's what it is, all right? So just like before, I'm going to kind of do this little table here. I have my x's. What x's do they want me to use? Those are the domain values. What x's are we using? 4, 6, and 8. 4, 6, and 8. And then what we want are the range values, which just happen to be the y values that we're going to get out. And so again, they gave me this rule, which is right here. X minus 5 is our little rule that we're going to plug in to figure out what the y is. What am I going to replace my x with first? 4. So we have 4, subtract the 5, what do we get? -1. Next, I'm going to plug in a 6. So I plug in a 6 and subtract 5. And what's 6 minus 5? 1. And last, I get to plug in an 8. So 8 instead of the x, and then a -5, and we get 3. So right here, these y values are the corresponding range values. Is that pretty easy? All right. I don't want to do another one of those because that's really easy. All right. But that's actually a test question that comes up a lot, like a M-STEP question or SAT question. That's weird, right? Okay. All right. Complete each function table and then graph the function. All right. Here we have our nice little equation. I know it's an equation because it's got an equal sign. And over here is our rule that we're going to use to figure out our x and corresponding y. So first, I'm plugging in -7, and then the +3. What is -7 plus 3? -4, beautiful. And so I get an ordered pair, -7, -4. And now we're actually going to go ahead and graph that and see what shape it makes. Let's see, where is -7, -4? 1, 2, 3, 4, 5, 6, -7, and down 2, 3, 4. So here is -7, -4. All right, what am I going to plug in next? -3, good. So I have a -3 instead of the x. -3 plus 3, what is -3 plus 3? 0. And so I have an ordered pair, -3, 0. How do I graph -3, 0? Left 3 and up or down nothing. So there's -3, 0. Beautiful. All right, what am I plugging in next? All right, so I have a 0 and then add 3. What do we get? 3. We have an ordered pair, 0 for x, 3 for y. How do we graph that? Yeah, go left or right, 0, and then just go up 3. 1, 2, 3. Good, good, good. All right, what are we plugging in next? 2, and then add 3. What do we get? 5. And so that gives me the ordered pair 2, 5, which tells me to go left 2 and up 2, 3, 4, 5. And last, we're going to plug in a 5 and then add 3 to it, which gives me 8. The ordered pair 5, 8. So let's see, that tells me to go 5 to the right. 1, 2, 3, 4, 5. And up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Hey, what's that? What do all those points look like? A line. Yeah, they're all in a really nice line. And this would continue. Could I choose a lot of x values? I could choose a whole lot of x values, and it would just keep going. So this forms a really nice straight line with a billion, trillion, million little baby ordered pairs. Okay. All right, let's look at equation 2 here so you can see the difference here. Our rule now is we're going to take our x value and we're going to square it. And so here, I'm taking a -3, and again, I'm replacing my x with a -3, and I'm going to square it. What is -3 repeated 2 times? 9. Positive 9. -3 times -3 is positive 9. So we get the ordered pair -3, 9. And here we're going to plug in a -2 and we're going to square it. That says, hey, what's -2 repeated 2 times? -4 or positive 4? Positive 4. It's -2 times -2, which is going to give me positive 4. So I have -2, 4. I'm going to plug in a 0 and square it. What is 0 squared? 0. So that's the ordered pair 0, 0. And if I plug in a 2 and square it, 2 times 2 is 4. So we get the ordered pair 2, 4. And last, we have 3 being squared, which is 9. 3 times 3 is 9. So we get 3, 9 for my ordered pair. And now we can go ahead and graph those and see what shape this one makes. So I'm going to graph -3, 9. That tells me go left 3 and up 9. -2, 4 says go left 2 and up 2, 3, 4. 0, 0 is right at the origin. And then we have 2, 1, 2, 3, up 4. And 3 up to 9. What is this shape? It kind of looks like a triangle, but it is actually going to give you a curve. It's kind of a U-like shape. But there it is. And you can see how different rules give us a different shape. So let's see here. This is, the first equation produces a line, which is what you all said. It was a straight line. And so it's called a linear, L-I-N-E-A-R, linear equation. Again, because it gives us a line. The second equation produces a curve. So it's called a quadratic equation. Well, it's called a quadratic equation, Q-U-A-D-R-A-T-I-C. And we're going to focus on graphing linear equations in this unit. So linear, again, means lines. We're focusing on lines. All right, turn the page. What do you suppose you need to do for these? Yep. Plug in, find the y, and then graph those ordered pairs. Yes, ma'am. Very good. Can you use a calculator if you want to? Yeah. Could you write the rule if you needed to? Could you write, like, here's my rule right here. I'm going to plug in -1, so -1 plus 6. And what is that? 5. Yep. And then we're going to plug in a 0 here. 0 plus 6 is 6. Plugging in a 2, what do you get? 8. 2 plus 6 is 8. And plugging in a 4, what do you get? 10. Do you have to write it out? No, if you can do it in your head, is that okay? Absolutely. Okay. Let's see. So -1, 1, 2, 3, 4, 5. 0, 6. 2, 8. 1, 2, 3, 4, 5, 6, 7, up 8. 4, 10. Can I graph 4, 10? It's off my graph. It's up here somewhere. You could put it up there. You can estimate that. That's okay. Does it make a line? Yeah, it looks pretty good. I want to look at number 2. This is kind of an interesting one. This is -x. You can think about it as -1 times the x value. So if I'm going to plug in a -5, what is -1 times -5? +5. If I plug in a -2, what are we going to get? +2. -1 times -2 is going to give us +2. If I plug in a 0, what do we get? 0. I love plugging in zeros. Makes life easy. And if I plug in a 3, what do we get? -3. -1 times 3 is -3. Beautiful. All right, so we have -5. 1, 2, 3, 4. -5, up 5. So left 5 and up 5. And then we have left 2, up 2. We have 0, 0, origin. And then we have right 3, down 3. And what shape do we get? A line. All right, let's just do one more. and we'll call it good. Are you feeling okay with this? Totally okay, right? Okay, good. One more, let's go down to number 8. All right, we have a negative 1/4 times the x. I don't know, maybe I need to write this one down a little bit. Negative 1/4, I'm plugging in a negative 8, and then I'm adding 2. What is negative 1/4 times negative 8?
2.
It is just a 2. Yeah, that becomes, you can think about it as 8 over 1 if you want. Straight across, we would have 8 over 4, and 8 over 4 is 2. Right. So we have a 2 plus a 2, which is going to give me a 4. Could you use your calculator if you needed to? Yeah, sure. I'm going to plug in a negative 4. Negative 1/4 times negative 4 plus the 2. What is negative 1/4 times 4? Positive 1. Very good. Plus 2. 1 plus 2 is 3. What do I get when I plug in a 0? 0 plus 2 is 2. And then I have negative 1/4 times the 4 plus the 2. What is a fourth of 4? Negative 1, yeah. So negative 1 plus 2 is 1. Good. So I'm negative 8 up 2, 3, 4. Negative 4, or left 4, 1, 2, 3, 4, up 3. 0 up 2, and 4 to the right, up 1. And there's our little line. All right, do you guys have questions for me? No. Okay. How come I chose these numbers for x? Because they're even, but also the denominator was 4, and all of these numbers are multiples of 4. And so I have a denominator of 4, and I'm choosing multiples of 4 to get nice answers. So 4, 8, 12, 16 would give you nice, pretty answers. All right, cool.